Good day, everyone. In today's episode, we will be talking about distance and displacement. Consider the 2 points A and B. Supposing we will trace an actual path from A to point B. Now, this actual path is called the distance. Next, we will trace a straight line from point A to point B. So, this straight line is called the displacement. So by definition, distance is the complete length of the path, while displacement is the direct length between the 2 points. Distance doesn't care about direction. Distance, therefore, is a scalar quantity. Distance over time is speed. So the formula is speed is equal to distance over time, or the formula is equal to s over t. Displacement, however, is concerned with the direction. Thus, it is a vector quantity. Displacement over time is velocity. By formula, velocity is equal to displacement over time, or small letter d over t. Now let me give you an example to illustrate my point. Determine the speed and velocity of a runner that completes an oval racetrack. The racetrack is 400 meters long and the runner completes the lap in 2 minutes. This time, we will identify the given values. The distance of the racetrack is equivalent to 400 meters. The displacement of the runner is equal to 0 meter because the runner returns back to the original position or starting line. The time it takes for the runner to complete the oval is 2 minutes, and that is equal to 120 seconds. Next, we will identify the formulas to be used. For speed is equal to distance over time, or small letter s over t. For velocity, that is equal to displacement over time, or small letter d over t. We now substitute the values for speed, that is equal to distance over time. Distance is 400 meters and the time is 120 seconds. Therefore, the runner has a speed of 3.33 meters per second. We now substitute the value for velocity, which is displacement over time. Since the runner has no displacement, so that will be 0 meter. And the time is 120 seconds. Therefore, the velocity of the runner is equal to 0. In conclusion, the runner has a speed, but it has no velocity. Let's have another problem. How far will the service bus overtakes the tricycle when the tricycle leaves a point that is 15 minutes earlier than the bus? The tricycle's average speed is 10 kilometers per hour, and the service bus average speed is 70 kilometers per hour. We will now determine the given values. The time of the tricycle is equal to t plus 15 minutes. The distance covered of the tricycle is just the same distance covered of the service bus because that is the distance where the bus overtakes the tricycle. So we are going to determine what is being asked in the problem. And that is, how far will the service bus overtakes the tricycle when the tricycle leaves a point 15 minutes earlier than the bus? Let us now determine the formulas to be used. Remember that we are talking about speed, and that is equal to distance over time. In rearranging the formula to find the distance, we will multiply both sides of the equation by time so that we can cancel time in the other side and isolating only distance. Therefore, distance is equal to speed times time. Since the distance of the series bus is equal to the distance of the tricycle, then let us equate the two formulas for distances. The distance of the series bus should be equal to the distance of the tricycle. Since distance is now equal to speed times time, that is also equal to the speed of the series bus times the time of the series bus is equal to the speed of the tricycle times the time of the tricycle. To substitute the values, that will be 70 kilometers per hour multiplied by the time is equal to 10 kilometers per hour multiplied by the time of the tricycle, which is the time of the series bus plus 15 minutes earlier. Since our formula uses the value of hour, we will now convert minutes into hour, and that is equal to 15 minutes times 1 hour in every 60 minutes. And that gives us 0.25 hour, or 15 minutes is equal to 0.25 hour. And so now therefore, the time of the tricycle is equal to t plus 0.25 hour. This time, we are now going to multiply the 70 kilometers per hour to time and the 10 kilometers per hour to the equation t plus 0.25 hour. This should now be the new form of our equation. We can now cancel hour into this equation. Therefore, 10 kilometers multiplied by 0.25 of a kilometer gives us only 2.5 kilometer. Multiply negative 10 kilometers per hour times time to both sides of the equation so that we can isolate 2.5 kilometers. And so therefore, the final equation will be 70 kilometers per hour times time minus 10 kilometers per hour times time is equal to 2.5 of a kilometer. Since time is common to one side of the equation, we can directly subtract 70 kilometers per hour by 10 kilometers per hour. That gives us 60 kilometers per hour times time is equal to 2.5 kilometers. We can divide both sides of the equation by 60 kilometers per hour to isolate time in one side. And so time therefore is equal to 0.0412 or is equal to 0.04 of an hour. Now that we have the value for time, we can substitute this to any of the two formulas to either the speed of the series bus or of that tricycle. In this case, we will be using the series bus. The formula distance is equal to speed times time will be substituted by the data of that of the series bus. The speed is equal to 70 kilometers per hour and the time is equal to 0.04 of an hour. The distance of the series bus is equal to 2.8 kilometer or kilometers. And so therefore, the series bus catches the tricycle at a distance of 2.8 kilometers. Consider the object. Its velocity is increasing every second. Therefore, it has a slower velocity here on the top, and the velocity is faster down. That gives us the new concept of acceleration. By formula, acceleration is the final velocity minus the initial velocity divided by the time, where alpha is acceleration in meters per square of a second, that is equal to m over s to the power of 2, and the final velocity is also in meters in every second, that is also equal to m over s. While v sub I is the initial velocity in meters in every second, that is equal to m over s, while t is time in second or seconds. A sample problem. What will be the acceleration of a car if it has an initial velocity of 1 meter per second until it reaches 4 meters per second on the fourth second? Using the formula for acceleration, the final velocity minus the initial velocity altogether will be divided by the time. So we substitute 4 meters per second as the final velocity, subtracted by the initial velocity of 1 meter per second, altogether divided by 4 seconds. And so the acceleration is equal to 0.75 meter per square of a second. In conclusion, acceleration therefore is the change in velocity in every second. It is sensitive to its direction, and so therefore acceleration is a vector quantity.